as we know, basically refrigerator is common household device that come with many usage. So nowadays, by using our advanced technology, smart refrigerator is being used to develop the usage of proper storing of food. And then, but this smart refrigerator come with a problem, which is it is high price, so it is not cost effective due to our life. And then this study present a refrigerator that using the PLC system of device, so it will come with more precise temperature and also high efficiency. So this PLC will use a control algorithm to analyze the input data to operate the system. And then the input data is include light regulator when the door is open, also the door sensor alert, and temperature display, also air purifier to remove the ethylene gas, thermistor looping, conversion of temperature from Fahrenheit to degree C, and also temperature regulator. So next we move to problem statement of this study. So firstly, we found that current generation of refrigerator typically using mechanical timer and also thermostat for each component. By using this component, this will result in imprecise of temperature control and also high energy consumption. It also lead to frequent breakdown and also the malfunction of this component. And then we can say that this component is wear out over the time. So it leading to loss of precision in temperature control, and also it can increase the risk of component failure. Hence, this study is come out with PLC-based control system refrigerator, by providing the more precise temperature control and also optimizing the compressor cycle by for the energy efficiency. For the objective of this project, it is to develop a highly efficient and reliable refrigerator control system that utilize the advanced capability of a PLC, which means that we want to design a new refrigerator that is fully controlled and also operate using the PLC system. So this objective can be achieved by conducting the process such as creating the ladder diagram for the system, and also run the simulation using the software, using the programmer.
A refrigerator uses a Mechatronics system to ensure proper cooling to the items through automatic temperature regulation. Mechatronics system in a refrigerator is to decrease total energy waste from unnecessary cooling temperature drop. Components of refrigerator consist of evaporator coils, condenser coils, compressor, capillary tube, freezer and chilling section, sensors, actuators and controllers. The functions of the mechatronic components is for automatic temperature, humidity, gases, water and light regulation. The way refrigeration system works is by firstly compressing the refrigerant into the outer coils. Then the environment absorbs the heat generated by the compression. The expansion valve allows the refrigerant to be sprayed from the outside coils into the inside coils in the freezer portion where it is supercooled. Then the refrigerant is then returned to the compressor via recirculation. A fan blows air into the refrigerator area to cool the entire appliance. The amount of air allowed to escape through the movable vent between the freezer and refrigerator sections determines the temperature in the freezer. The vent in this system essentially regulates the temperature ratio between the freezer and refrigerator. There are many sensors that can be used in a refrigerator mechatronic system. The sensors used give multiple different functions and features to the refrigerator, but the most significant sensors that impact the quality of the refrigerator is as per below. There are 5 sensors that works to detect different inputs in the refrigerator mechatronic system. The first one is DHT11 temperature and humidity sensor. It can detect the change in the environment temperature and humidity level. The differences in temperature and humidity can be decreases to achieve desired temperature, and the freshness of the food can be maintained. Next sensor is MQ3 gas sensor. It detects any unwanted gases produced by the spoiled food, ethylene. Then it will send a signal to user and remove unwanted gases through air purifier system. Next sensor is leaking sensor. It identifies an alert to any refrigerant leakage. Internal pressures in the refrigerant are often higher than air pressure. All refrigeration systems have the potential to leak. It can minimize the environmental harm and ensure refrigerator efficiency. Next sensor is infrared sensor. It can detect objects within 4 to 30 cm. Refrigerator display will be light up when a person approaches the refrigerator. It can reduce the energy consumptions when compared to conventional refrigerator display. Final sensor is door sensor. It works by detecting the angle of the door opening, and as the angle of the door opening increases, the light intensity in the refrigerator also increases. It works by, rather than directly emitting electric current to light up the refrigerator, this system reduces the overall energy by lengthening the response time and slowing down the bandwidth.
For the methodology, PLC in the refrigerator. So a ladder diagram was created using the plcfeeder.com. The ladder diagram is to simulate the functionality of the model refrigerator. So the fridge consists of light regulator, door alert, fridge control panel, air purifier, and temperature regulator. So for the light indicator, a normal open switch is used to control the light indicator. For the door open alert, the light indicator is set as a normal open switch to control, and on delay timer is used to delay the current flow for 10 seconds. Next, for the control panel, off delay timer is used to control and delay the current flow for 5 seconds. For the air purifier, the light indicator is set as a normally closed switch to control, and on delay timer is used to delay the current flow for 5 seconds. For the last functionality, temperature regulator, the temperature will be measured in the Fahrenheit, then it will be converted into Celsius. The measured temperature will be compared with the preset temperature. For the fridge is 4 degree and the freezer is -18. Okay, so here is the PLC simulator. So for the first round, we have door pin as the normally open switch, and we have light indicator. So when the door of the fridge is open, the current will flow and turn on the light. For the second round, we have a on delay timer. For a 5 second, it will delay the current flow to the alert. So if you can see here, if you turn on the switch for the light indicator, for 5 seconds, it will on the alert button. For the third round, we have off delay timer. It controls the control panel. So after we after we open the door of the fridge, it will immediately on the control panel. And after we close the door of the fridge, it will delay the current flow for 5 seconds. For the fourth round, we have a light indicator as a normally closed switch. So when we close the door, the switch is in closed state. So the current will flow to the air purifier and turn on the air purifier. So when we open the door, it will cut off the current flow and turn off the air purifier. But if we close the door back, it will delay the current for 5 seconds to flow to the air purifier. Next, we have looping for the sensor to measure the temperature inside the fridge. So we have 3 rounds. So the first round is sensing temperature with the switch normally open. Second round we have a timer, gap sensing timer, on delay timer, and third round we have a sensing timer, on delay timer. So here the current will flow on and off to loop the sensing of the temperature inside the fridge. Next, we have thermistor. When the looping is on, so the thermistor here is we close and allow the current to flow. So the current will flow here to convert from the measured temperature in Fahrenheit to Celsius. So the formula to convert the Fahrenheit to Celsius is we will subtract the input temperature minus by 32, and the answer will be divided by 18. So the Fahrenheit, the R here is to make sure it will only measure in one time. So after it complete the calculation, subtraction and division, so it will give the value to the comparison at the second and last round. So here is for the compressor for the fridge and compressor for the freezer. So if the normal temperature, the measured temperature calculated is more than the preset temperature for fridge, which is 4 degrees Celsius, and for the freezer is negative 18. So when the condition is true, it allows the current to flow and turn on the compressor for both compressor, fridge and freezer. So if the condition is false, for like these cases, the normal temperature is lower than the preset fridge and freezer temperature. The normal temperature is negative 20 degree, and the preset temperature for the freezer and fridge is negative 18 and 4. So it falls the condition and not allow current to flow to the compressor and compressor fridge and compressor freezer.
For the result discussion part, in the constructed ladder diagram, it consists of 8 major functions that are useful during our daily life to ensure that the food we insert to the refrigerator being stored in a fresh and prolonged food shelf life conditions. Therefore, from the result that finalized constructed for the refrigerator system, when we open the refrigerator doors, a light will be on and an alarm will be triggered after some time, which depending on the delay timer where the timer being set. Next, for the control panel, which located at the outside of the refrigerator, will also be switched on when the door of the refrigerator is in open conditions. The control panel of the refrigerator can be several functions. The control board is the brain of the refrigerator and collects the sensory input from numerous sensors in the freezer or food sections. The runtime of the compressor, the number of times the doors have been opened, the fans, and so forth. So, furthermore, when the light is off means the door is closed, the air purifier will be switched on, which will then catches airborne contaminants inside a refrigerator, and it is installed in the black back panel of a fridge to deodorize and clean the intake air as well as the circulating air inside, keeping a good fragrance or smell in the internal compartment. From the methodology part, we can notice that from the round 6 until the round 8, is looking for the sensor temperature. Therefore, when the refrigerator is in power on conditions, the sensor temperature will then detect the interior temperature continuously until the power is cut or either switched off. For the round number 10 is where the conversion of the temperature detected will be converted from Fahrenheit to Celsius take place, where the only calculation will be carried out and continue in the comparing function in the next function of the ladder diagram constructed. This next function will compare both the normal temperature with the fridge temperature and the normal temperature with the freezer temperature, where the value of the natural temperature is -20 Celsius, value for the fridge temperature is 4 Celsius, and the value for the freezer temperature is -18 Celsius. When the value of the normal temperature is bigger than the temperature of the freezer and the fridge, the compressor will be activated. Thus, the temperature in the refrigerator will be lower, which ensures the internal temperature is cool enough to function normally. On the other hand, when the normal temperature is less than the freezer and fridge temperature, the compressor will then stop operating. Lastly, the time where the refrigerator switch on, the checking fridge and the checking freezer will be operating non-stop for the function of the temperature verifications if got current flow until the entire manpower of the refrigerator been switched off. Thank you.
In conclusion, a highly efficient and reliable refrigerator control system that utilizes the advanced capabilities of a PLC has been developed. The ladder diagram constructed helped the researchers to understand the working principle of a refrigerator efficiently. The mechatronic system that are implemented in the temperature regulating control system has helped preserving the quality and extending the expiry date of food. The timer sensor help remind the users of a refrigerator of an unclosed door. This helps users to save energy as the compressor can be preserved from doing extra load. And moreover, a leakage detector alerts the user of a problem that may cause health and safety hazard, as leak water and other liquids from the refrigerator may attract parasites to contaminate the area and endangering the life of users. Besides, the leakage may also cause the users to slip and fall, causing injuries or even fatalities. Air purifier sensors, on the other hand, helps to remove ethylene gas released in the refrigerator to give comfort to the user as well as preserving the food better.